So we're starting our unit on trigonometry, which is still dealing with right triangles in our chapter on right triangles. And we're going to start by just looking at tangent. So you're going to want your calculators out. So we're going to learn some new buttons on there. Today we're just going to be learning how to use the tan button, which is short for tangent. And then the next section we're going to learn sine and cosine, which are right next to that button. So what sine, cosine, and tangent do, or trigonometry, they find a missing side of a right triangle if you know at least one angle measure. Okay. They also find angle measures, but we'll get to that 2 sections from now. So talking about tangent of an angle, the angle is always right here, is going to be equal to a ratio. Okay, and the ratio is always going to be opposite over adjacent. Okay, so we're going to start just by learning how to set these problems up, because solving them is always going to be the same process. So we're going to look at these triangles right here, and we're going to be focusing on the angle that has the letter A in it. So let's just go through and mark these angles so we know where to focus our attention. Now on each of these right triangles, there are sides that we can label as the opposite side, the adjacent side, and also the hypotenuse. Tangent isn't going to be using the hypotenuse, it only uses the opposite and the adjacent sides. So looking at angle A right here, if you were to draw an arrow pointing straight out, it always points at the opposite side. Okay, so I'm just going to label that. Now adjacent means next to. So looking at angle A right here, there's actually 2 sides that are adjacent to the angle. But one of them has a special name, which is the hypotenuse. So this is the hypotenuse, leaving this one to be the adjacent. So the tan of A, because remember the angle always goes right after tangent, we just want to set up what 2 sides they're talking about. Well, if it's this one, the opposite is 12 and the adjacent is 5. Okay, so using that same idea on the next one, we've got tan A equals, and now we want the opposite side from angle A. Remember, you can always draw an arrow and it points at the opposite side, 33, over the adjacent side. And make sure you aren't picking the hypotenuse, even though it's adjacent to it, because that one has that special specific name. So the one adjacent to it that isn't the hypotenuse is 10. On the next one, tan A, the opposite side straight across from the angle is 8, and adjacent to it is 25. On this one, tan A, opposite across from it is 9, and adjacent to it, we don't want to pick the hypotenuse, adjacent to it is 35. Now, none of your homework problems are going to be asking you to set them up. This is just the first step in solving for these. Now, on all of these problems, we don't have any variables. This was just learning where do I put the sides and the angle and all of that. So this is the setup process. Now we're going to learn how to take it one step further and actually solve for a missing number where there's a variable. So on the next page, we've got some examples to work through. We've got 5 of them. Okay, so again, you should have your calculators out because we're going to be using the tangent button. On all of these, there's an angle that's filled in with a degree besides the 90 degrees. That's where we're going to focus our attention. Okay, so on this first one here, let's just set up the problem. Okay, we've got tangent. What always goes right after tangent or sine or cosine? Okay, the angle does. So tan 30 is equal to, now we need to put opposite over adjacent. Okay, I'm going to label these with those letters. So we've got the opposite side and the adjacent side. We want to make sure we put them in the right order or the problem won't be correct. Okay, so we're going to do opposite over adjacent. Okay, now we'll go through and solve that in a minute, but let's just make sure we are still able to set these up like we were working through on the previous slide. Okay, so on this one, we have our angle. Okay, we've got 44, so we've got tan. We always put the angle here. And then we do opposite over adjacent. Same setup every single time. Here's our angle on this one. We have tan 55. And then we want to put the opposite side. Remember, if you draw an arrow straight out, it points at the opposite side and the adjacent. We'll go to the lower left over here. Got our angle. Tan 37. And we want to do the opposite side over adjacent. And the last one. Here's our angle. We've got tan of the angle, and then we want to do opposite over adjacent. Okay. Now the solving piece of it. Whenever you have a fraction, it's nice to get rid of the fraction. And in order to do that, let's look at that top middle problem, for instance. Right here. Right now on the right-hand side, x is divided by 17. Okay, to undo division, or a fraction, you just multiply by the denominator. Okay, so if we multiply both sides by 17, now on the right-hand side, the 17's canceled out. And we have x equals 17 tan 44. Well, x is by itself at this point. Okay, so what we're going to do is find the answer. Okay, so in your calculators, you're just going to type in exactly like you see, 17 tan 44. Now this is only if you have a TI-30X, which most of you do. If you don't have a calculator where you can see what you're typing in, you're going to have to work backwards. Okay, so you would actually do 44 and then hit your tangent button and then times 17 and equals. Okay, that's if you have a calculator where there isn't two lines of work on the screen where they have what you type in and then your answer underneath it. You would go completely backwards. Okay, so that's the answer for this one. We just figured out how long that side is. Okay, so let's move to the right. Let's go right here. What would we multiply both sides by? We're going to do 8. Okay, so now on the right-hand side, the whole reason we did this, the 8's are gone. Left with just x over there. 8 tan 55. So we put that in the calculator, and we get 11.43. We just figured out the height of that triangle right there. Okay, let's move in a circular fashion. We'll do this one in the lower right. Multiply by the denominator. Okay, we found that one. Okay, now the last two I've left for the end for a reason. I'm sure you can see why. Okay, what do we multiply by on both sides? Well, we need to multiply by the denominator, and in this case the denominator is the variable. That is okay. Okay, so if we do that, the x's cancel out on the right. Okay, but now we don't have a fraction to deal with anymore. How would we get x alone at this point? Okay, well, let's think about it. We've got x, tan 30 is one item. Okay, that's a number. Okay, if you put in the calculator, you get a decimal answer. That's a number. So right now, they're being multiplied. So to undo that, we're going to divide by tan 30 on both sides to get our answer. Okay, well, in our calculators, we're going to put exactly what you see there, 7 divided by tan 30. 12.12 is what I get. If you don't have a calculator, a TI-30, and you need to put that in, you're going to do this. I'll just put a little side note here. You're going to do 7 divided by 30, then hit your tan button, then hit equals. Okay, so when you have a calculator where you can't see what you're typing in the line above, essentially you just have to switch the 30 and the tan compared to what all the rest of us are doing in our calculators. It's good to just get a TI-30X. They're really slick to use. Okay, this last one. Tan 37 equals 54 over x. Process never changes. We always multiply by whatever's in the denominator. The x's canceled out, leaving us with just 54 on that side. And now we need to get x by itself, because that's what we're trying to solve for. So we're going to take 54 divided by tangent of 37. Get 71.66. Questions on that? All right, let's try one more problem on the last slide. We want to know the perimeter. Well, right now we only have one of the three sides, and in order to find the perimeter, we need all three sides. Okay, so let's put an x down here, and then we'll use what we learned today to figure out what x is. Okay, so we've got our angle here. We've got our opposite side and the adjacent. So let's get started on this. We've got tangent of the angle equals opposite over adjacent. We always multiply by whatever's in the denominator. In this case, it's x. So now we have this problem, but we're still trying to get x by itself. So we have to move the tan 42 to get our answer. Okay, so we got 12.22, which is the length of that side right there. Now we have a triangle that looks like this. Let me redraw it for us. 11, 12.22, and we're trying to find this. What have we learned in this chapter that would maybe help us at this point? We have two sides of a right triangle. We want to know a third side. That's when we want to utilize our Pythagorean theorem. Okay, remember the important part in Pythagorean theorem is your c squared. So which one is going to be c squared? Okay, well c squared has to be this, the hypotenuse. So we've got 11 squared, 12.22 squared, and y squared. Well, if we square these two numbers, got 121 here, and 149.3284 here. When we add them together, we get 270.3824. There's only one step left in order to find the length of that side of the triangle. Square root that number. We get 16.44. Well, the original question was to find the perimeter. The perimeter is the sum of all the sides. So we'll take 11 plus our 12.22 plus 16.44 and get 39.66, and it says rounded to the nearest whole number, so this should be 40. So I said in a previous section that everything we're learning in this chapter about right triangles is going to show up in multiple places, most of them being on standardized tests. So when you take the ACT, or you take the ASVAB, or you take an AccuPlacer for a college to see what classes you're going to be assigned to, you're going to see right triangles, and you're either going to be using tangent, sine, cosine, or you're using Pythagorean theorem. And this shows you a combination of the two of them.